So Davide asked me, I asked him, I guess a week and a half, 2 weeks ago, what would be the most useful topic for me to focus on. And he sends me back this long topic that talked about getting media attention and raising awareness and all that. And I had to say that my first reaction was, what's that all about? Because we've been in this business, AES been doing energy storage for 7 years. We're doing real business. It's a profit center within our company. It's not a cost center. I see on my internet, on my email, like every day, there's like 2 or 3 storage articles. So I'm like, what's all this about awareness? But the more I thought about it, I thought maybe I could offer a few ideas. And I decided I'd focus on 3. One would be that instead of us as a group focusing on all of the high cost, incentive-based needs and things that aren't working, I'd like to see us as a group focus on what is working. And I know AES isn't the only company that has projects that are making money, they're competitive, they're saving customers money. I know there's others of you out there that have similar experiences. So that would be my first topic, and I'll talk about what AES is doing in some level of detail, and hopefully others of you will be able to educate us on what your companies are doing. The other thing I want to discuss just briefly is kind of the European need for grid-level energy storage. And when I peel back those needs, a lot of those needs are the same things that we're seeing in other parts of the world. So I just want to have a bit of a discussion about that. And finally, in terms of as a business model, energy storage, rather than us looking for subsidies as an industry, I'd like to have us look at how we can change codes that were written at a time when energy storage wasn't what it is today. So obviously that's not in the codes. Fix those codes so that they properly reflect the benefits that energy storage can offer. A bit about AES. We're a utility. We serve utilities. We serve system operators. We deal with regulators. We're very diverse, both geographically and technology-based. We're essentially in everything except nuclear. You can see kind of, world leader in battery-based energy storage is not from me. That's coming from the outside. And I believe modestly it's just because we have a fair amount of capacity that's being deployed on the system. A bit about kind of how this all got started. I was there in Indianapolis in the first kind of deployment of lithium-ion storage. And it was exciting back in 2008, but I could say back then it started kind of a bit as a pilot. So I'll use that word maybe only once today. We then moved into two paths, essentially. Chile, which merely was a spinning reserve replacement. So in Chile, there's requirements that each utility has to have a certain amount of spinning reserve to be deployed in the event of a system emergency. We basically said, why can't, instead of that generator backing down, why can't we just put our batteries on the facility site, and to the extent that ramp up, go ahead and run the plant at its designed full load, optimal load, and if there's a problem, we'll use the batteries to deal with the problem. It's been a successful model. The other path that we've taken has been more of the frequency response, the fast response angle, and that's been essentially serving a number of the regional markets, the regional transmission markets, the most recent one being PJM. The Johnson City installation is no longer there. It was in New York. The market ended up not being as attractive over time as other markets. The beauty of battery-based energy storage is we just took it and we moved it to where it was more appreciated and there were greater benefits to customers. I talked about resource. The headline here says 172 megawatt of power plant equivalent resource, and we just announced yesterday some 540 megawatts of resource in development and construction. And when we talk about resource, the reason we do that, it's essentially double the interconnect capacity. And when you think about it in terms of a standard power plant, assuming there's no minimum load requirement, you have a 100 megawatt interconnect, and the system operator wants you to fluctuate all the way up to 100, so 50 net ramp up, and wants you to also ramp down by 50. Your effective power that you're generating is 50 megawatts. In the case of battery storage, same 100 megawatt interconnect, but you start at 0, and within a third of a second, you're up to the full 100 megawatts, and just a third of a second later, you're down the full 100 megawatts. So it's essentially actually more than double if you consider minimum load of typical gas generation, and that's why we refer to it as a resource. How we do it is pretty simple. It all starts with a C-level, C-cell type battery, and I know when I first got involved with storage, it's like, okay, this is a little bizarre. You're using basic household kind of components batteries, and you're essentially scaling this up to, you know, shipping container like levels that are multiplied. I would have thought there would be some kind of special plasmatic half-life of a zillion years kind of technology you paint on the wall, or, you know, something really exotic. But when you think about it, a C-cell is what? It's safe, it's abundant, it can be recycled, and then it can be scaled. And all of those things ultimately work to add value to the projects that we deploy. This is a bit of a cutout of a project that it's a rendering of a project that we won in California, and looks at more of a data center component. But again, if you look at from a reliability standpoint, again, if you break it down to that lowest level, if you have an integration issue, if you have a system failure in any one of those levels, you don't lose the whole 100 megawatts in this particular case. Over history, we've proven to be about 97% reliable, and if you look at the amount of hours that a peaker is on, 6.6% of the time, clearly there's a reliability benefit. I mentioned California. This has been in the news. It's an exciting project for us, and it does a couple things. One, I'd like to think it debunks the myth that energy storage, at least battery-based storage, is expensive, because we've all heard it. We all even admit it. I've heard it today. And this was bid in, this bid was bid in against peaking capacity that I'm told with computer modeling, there were thousands of individual bids that were turned in. And this beat out not just battery-based storage, not pumped hydro, not other forms of storage. It beat out every kind of capacity that existed and that was bid into California, battery storage. And we know, and it's public, that they wanted to pick even more of that. And so what our plan is, if you look at the area to the top of the building, there's enough room for 2 more of these units. And our plan, ultimately, we believe, will be to, instead of just 200 megawatts of resource, we'll add an additional 400 for 600 megawatt of resource, because California needs that resource. The benefits, I think people are generally aware of. You've heard some of them today. The modular, scalable, portable, I've discussed. I won't get into that. The second thing is about, the second topic that I wanted to, again, this is about generating awareness, us as an industry, making sure people know what we're doing and how valuable it is. It's a bit of an investigation of, okay, what are Europe's grid needs? I talked about the Chile example. Certainly, I know in certain parts of Europe there's a requirement to hold on to spinning reserves. We talked about the frequency market that we have going in the US, and I know there's an active market in Europe as well. The renewables is huge, obviously, the penetration. For me personally, as a big renewable fan, that admittedly I was a bit skeptical early on. The exciting thing for me about energy storage is it now demonstrates that ultimately there won't necessarily have to be curtailments on wind energy anymore. That wind energy and solar energy and renewables are limitless when it comes to offsetting the challenges with battery-based storage. The other thing we've found elsewhere is that wherever a peaker makes sense to deploy, let's say to get around a transmission issue, a transmission bottleneck, wherever a traditional peaker can be deployed, the energy storage, battery-based storage can do the same thing, better, cheaper, faster, more flexibly, as I've indicated. So we see it as a real benefit to relieve transmission-related issues. This is the famous duck curve, and I saw a couple of examples of this this morning. And I don't seem to have a laser, or maybe this is. No. That's black. I don't have a laser pointer. But I'll just come over to the slide. If you look at this top curve, the very top of the curve, this is essentially the net consumer load, and this is a California graph, as dampened by solar radiation, solar generation during the day. And the top line, the top curve, is 2013, and the estimate all the way to 2020, with the additional penetration of renewables, that's the kind of curve that will generate. And the issue for California, safety first, the issue for California is when that solar goes down and people are coming home for dinner and doing the normal household kinds of things and using electricity, that ramp has to be dealt with. And right now, the ramp is being dealt with by starting traditional fossil-based generation early so that it can ramp up in enough time to serve the load that needs to be served. And so I've seen the curves. They're here in Europe as well. Europe's a leader in renewable generation and policy. It got the world going. And so fast-based energy storage can essentially react to that curve and allow the traditional generation to not start early, start on time, and ramp up within its capabilities. Just a bit, I mentioned about the transmission issue. Obviously, everywhere around Europe, there's transmission issues. There's projects that have been proposed. There's connecting the renewables in the north with the challenges in the south, et cetera. A good application. There's these projects of common interest that are published that we can all bid on. I don't know if all of those projects have now been approved and are ready to go. I don't know how many of them could be offset if you looked at the potential for energy storage, but there is something there, and we'll find that with proper deployment of storage, we can get rid of some of the siting issues and the contentious issues related to adding new transmission capacity. We saw this curve, this Pike research curve early this morning. The comment was made in solar. We actually found that the ramp was steeper. I fully believe that. The other comment was made that in solar, the cost ended up being more. I'd like to suggest that that isn't going to happen here, but obviously time will tell. We're getting on board with Europe for our first two projects. This one was previously announced, but it's intended to be, this is a rendering for a 100 megawatt unit up in Northern Ireland at our Kilroot facility, the first 10 megawatts of which we intend to have online by the end of this year. The other project that we just announced yesterday was a project in the southern province, the Zeeland province of the Netherlands. This is a 10 megawatt project that ultimately is expandable to whatever the market solutions required will be. That one will have finished and online by the end of the year as well, this year. Real projects. And finally, so I covered the fact that we're deploying energy storage today. It's competitive. I covered the fact that the Europe needs, the transmission, the renewables, all of that are similar to what we see elsewhere. And the final area is this idea, and I've heard the word subsidy a number of times. that somehow we need to focus on getting the codes right and getting the regulation right so that we don't need the subsidies, right? Because obviously real markets shouldn't be based on subsidies. So I looked at 3 off the top of my head that I felt like were pretty significant ones that we should focus on. The pay for performance. I think there's some question of whether it's for 455 or 555 or 75. I'm not sure where the number, but the whole issue of pay for performance was a key one that I'll mention. The other one is the duration, and that's the amount of time that once you're called on by the system operator to dispatch, how long that you should be dispatching in an upward or a downward direction. And finally, the transmission fees, which is about how the system codes treat us as energy storage as a consumer, as opposed to a normal combustion turbine, for instance, that would kind of be netting its power. So I'll just go in briefly with those 3 things. The pay for performance we talked about, and that is the issue of that the Federal Energy Regulatory Commission in the US basically recognized the value of storage and said, you guys need to get your grid codes together and make sure that you properly reflect dual payment structure that says energy storage, response rate, and mileage are superior to traditional generation. You need to pay for that. PJM was the first regional transmission operator to reflect that FERC order in its codes. And the key to all of this is we wouldn't be doing this if ultimately there wasn't a consumer benefit. There's not a market without a consumer benefit. So basically what PJM said is during the first year, when they did this pay for performance, it caused them to procure less traditional generation to provide frequency response because they were able to get faster response battery-based service. And it saved them $20 million in year 1. I don't know what it saved since. I don't know if that's public record, but not a small sum. We talk about mileage. This is essentially a 1-day period, and this is our Laurel Mountain facility that modulates between 32 megawatts up and 32 megawatts down. And this is what a day looks like in this battery's life. It's going up and down like this. And this is what about 40 seconds does in that battery's life. So you can see that there's no one frequency event that lasts very long. But because of this mileage, this is like mileage on your car. The more mileage, the more taxing it is on the battery. So these pay for performance issues are attempting to reflect not only the fast response benefit, but also the ultimate cost that has on the battery. In terms of duration, I mentioned the no frequency event is very long. We've kind of looked at this and found that the battery is most effective at the shorter duration, and PJM has recognized that as well. So requires a 7.5 minute duration in either direction. And what we did is study how PJM's standard frequency duration curve measured up against some of the major European markets, and found that actually this is the amount of time that the battery is essentially at 0, and then going upwards and downwards in the direction. And basically it says that the actual peak in Europe in some of these major markets, I think this one might be Germany, is actually tighter, shorter, more constrained than PJM. So duration is key to energy storage, and it doesn't need to be long to be effective. And then the final comment relative to fees is again, as a battery, you give power to the system, and then you take power back to charge back up. And that's just constantly changing with mileage. And what we need to do with the rules is make sure they recognize that this is essentially borrowing just to give back, and it's not really a consumer. And those rules need to be worked through. So, Davide, I don't know if I hit exactly the target about media attention, awareness, and acceptance, but my goal was to, at least from AES perspective, let you know the real things are happening with real customers, with real business. It's happening today that Europe has some significant issues with transmission grid support, renewable integration, all those things, as do other places in the world where battery storage has been able to resolve many of those issues. And finally, we're asking for subsidies rather than, or seeking code changes rather than subsidies is the way we should go about creating awareness. That's it.
Thank you so much.
Okay.